Let's now have a look at the power rule. The logarithm of an argument x that has an exponent n is equal to the logarithm multiplied by the same number n. So let's say we have the log of base b of x raised to a power of n. This is equivalent to the log of base b of x being multiplied times n. So we take that exponent and we move it from the exponent of the argument to the coefficient of the logarithm. But before we look at any examples, let's work our way through the proof of this rule. The log of base b of x raised to a power of n, and that's equal to n times the log of base b of x. So let's first take the log of base b of x, and let's set that equal to some number m. We can change this to exponential form now by taking our base b, raising it to a power of m, and setting that equal to x, our argument. And now with b to a power of m equal to x, since x is by itself, we want to now raise x to a power of n. So we'll raise this side to a power of n, and we'll raise this side to a power of n, giving us x to a power of n over here. And on this side, we have b to a power of m to a power of n. Here, we would multiply these exponents, giving us b to a power of m times n. And that's equal to x to a power of n. And now that we have x to a power of n, we now want to take the log of base b. And since we're going to do that on one side, we want to do it on both sides, giving us the log of base b of x to a power of n, which is what we're looking for. And now on the other side, we have the log of base b of b to a power of m times n. And the inverse rule lets us know that when we have a log of base b to an argument that has a base of b, we can negate those, leaving us with the exponent m times n, which is equivalent to n times m. And here we see that m is equal to the log of base b of x. So on this side, we wind up with n times the log of base b times x. And that's equal to the log of base b of x to a power of n, bringing us back to our original statement, the power rule. So now that we see that this rule is true, let's take a look at a few examples. So let's say you had the log of base b of x squared. X squared is x times x. And x times x, we can now use the product rule here to separate this into the sum of two logarithms, which would be the log of base b of x plus the log of base b of x. And x plus x would give us 2x, since we have two x's. This is the same. The log of base b of x plus the log of base b of x would give us 2 log base b of x, since we had two of them. So we see we started with the log of base b of x squared, and that is equivalent to taking this exponent 2 and moving it to the front of the logarithm, which would give us 2 log base b of x. So this is just one example of how to use the power rule. Just like the product rule and the quotient rule, we'll be using the power rule in two different scenarios. The first, we'll be using it to combine terms, and the second, we'll be using it to expand terms. So let's begin with the first use case. Logarithms with coefficients can be reorganized using the power rule and then combined using the product or quotient rule as long as they have the same base. So 2 log of 3 minus 4 log of 2 can be combined to give us the log of 9 divided by 16. Now there are a few steps not shown here, but let's walk through the process of taking this expression and winding up with this expression. Let's say you were asked to combine the terms and simplify if possible. and this is the example we just saw, 2 log of 3 minus 4 log of 2. Step 1, move each coefficient to the exponent of the argument. So in our first term, the coefficient is 2, so we'll move that to the exponent of the argument 3. Here, whatever number, including the sign, is in front of the log, we will use as the coefficient. So negative 4 is the coefficient. So we'll move that to the exponent of the argument 2. By doing it this way, by moving the negative as well, here we will always wind up with a positive. But just note, you can remove the 4 at this step here, but you would need to keep the negative. At the end of the process, you'll wind up with the same answer as long as the arithmetic is taken care of correctly. But throughout the remainder of this chapter, just to let you know, I will be moving the negative with this coefficient. So at this step, we will always wind up with addition, but you can remove the number and leave the negative if you'd like. Just wanted to make that clear at this step here. So again, we change 2 log of 3 to the log of 3 raised to a power of 2. And we take negative 4 log of 2 and change that to the log of 2 raised to a power of negative 4. And now, step 2, we want to combine the logarithms by multiplying the arguments. So this is where we're using the product rule. Since we're adding logarithms with the same base, these are common logs since the base is not shown. That means we can combine them by multiplying the arguments 3 squared and 2 raised to a power of negative 4. And now we've successfully taken 2 logarithms and combined them to a singular one. And now we want to evaluate the argument here. So we have 2 raised to the power of negative 4. So that can be changed to 2 to a power of 4 if we move this to the denominator. And now we have 3 squared, which is 9, and 2 raised to a power of 4, which is 16. So we see that 2 log of 3 minus 4 log of 2 can be combined to give us the log of 9 over 16. So that is how we go about using the power rule to combine terms. Let's now have you try a few practice questions. Combine the terms and simplify if possible. Question number 1. Negative 3 log of 5 plus 2 log of 4. Question number 2. 5 log of 2 minus 3 log of 4. Question number 3. 4 log of 3 minus log of 9 plus 2 log of 6. And question number 4. Negative 2 log of 7 plus 3 log of 2 minus log of 4. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were given negative 3 log of 5 plus 2 log of 4. Step 1, move each coefficient to the exponent of the argument. So we'll take our first coefficient, negative 3, and move it to the exponent of this argument 5. And for our second term, we'll move the coefficient of positive 2 to the exponent of the argument 4. And that leaves us with the log of 5 raised to negative 3 plus the log of 4 raised to the power of 2. And since we are adding 2 logarithms with the same base, we can use the product rule to combine these 2 logarithms into a singular logarithm by multiplying the arguments. And now once we've done so, we can evaluate this argument. So we can move this term with a negative exponent to the denominator and make the exponent positive now. leaving us with the log of 4 squared divided by 5 cubed. 4 squared is 16, and 5 cubed is 125. So we find that negative 3 log of 5 plus 2 log of 4 can be combined to give us the log of 16 divided by 125. So that is the answer to question number 1. Let's now have a look at question number 2. We were given 5 log of 2 minus 3 log of 4. Step 1, move each coefficient to the exponent of the argument. So we'll move this coefficient of 5 to the exponent of this argument 2, giving us 2 to a power 5 here. And for the second term, we'll move the coefficient negative 3 to the exponent of the argument 4. So we wind up with the log of 2 raised to a power 5 plus the log of 4 raised to a power of negative 3. And now, since we are adding two logarithms with the same base, we can combine these two terms by multiplying the arguments 2 to a power 5 and 4 to a power of negative 3. And now we've combined two logarithms into one. So now we can evaluate the argument. So we can move this term with the negative exponent to the denominator, which would leave us with 2 to a power of 5, which is 32, divided by 4 to a power of 3, which is 64. And 32 divided by 64 is equal to 1/2. So the answer to question number 2 is 5 log of 2 minus 3 log of 4 is equal to the log of 1/2. That is the answer to question number 2. Let's now have a look at question number 3. We were given 4 log of 3 minus the log of 9 plus 2 log of 6. Step 1, move each coefficient to the exponent of the argument. So for our first term, we move the coefficient of 4 to the exponent of the argument 3. For the second term, our coefficient is negative 1, so we move that to the exponent of the argument 9. And for our third term, we move the coefficient of positive 2 to the exponent of the argument 6. So this leaves us with the log of 3 raised to a power of 4, plus the log of 9 raised to a power of negative 1, plus the log of 6 raised to a power of 2. And now we can combine these logarithms since we are adding logarithms with the same base. We can combine all three of these into a singular logarithm by multiplying the arguments. And now we can evaluate this argument. So we'll begin by moving this term with the negative exponent to the denominator. And that would leave us with 3 to a power of 4 times 6 squared in the numerator, and 9 to a power of 1, which is just 9 in the denominator. And now we can simplify this further. 3 to a power of 4 is 81 times 6 squared, which is 36. 81 divided by 9 is 9, so that will leave us with 9 times 36. And 9 times 36 is equal to 324. So we find that 4 log 3 minus log 9 plus 2 log 6 is equal to the log of 324. And that is the answer to question number 3. Let's now have a look at question number 4. We were given negative 2 log of 7 plus 3 log of 2 minus the log of 4. Step 1, move each coefficient to the exponent of the argument. So we move this coefficient, negative 2, to the exponent of this argument, 7. We move this coefficient of 3 to the exponent of this argument 2. And we move this coefficient of -1 to the exponent of this argument 4. So after this step, we wind up with the log of 7 to a power of -2, plus the log of 2 to a power of 3, plus the log of 4 to the power of -1. And each of these are a common log with a base of 10. So since they all have the same base, we can use the product rule to combine these logarithms into a singular logarithm by multiplying the arguments, 7 to a power of -2, 2 cubed, and 4 to a power of -1. And once we do so, we can evaluate this argument. So we'll begin by moving the terms with the negative exponents to the denominator, leaving us with 2 cubed in the numerator. And now 7 to a power of -2 becomes 7 to a power of +2 in the denominator. And 4 to a power of -1 becomes 4 to a power of +1, which is just 4 in the denominator. And now 2 cubed is 8, and 7 squared is 49. 49 times 4 is equal to 196. And 8 divided by 196 can be simplified to 2 over 49. So this shows us that -2 log of 7 plus 3 log of 2 minus log of 4 is equal to the log of 2 divided by 49.